Niti, mute your microphone. Yeah, so it is, I say it many times into your class that it's not useful that, if you are coming to the class, giving your attendance, and you're staying, you are doing some other activities if you're not listening us, because you can miss out some of the very important information. And due to that, actually, your grade is going to become poor at the end of the semester. So I would like to request you again that please, make sure that you are in the class time, you are stopping to do some other activities rather than the class. Listen to the lectures, not only for this course, but for all the courses that you have registered. It is good for you, okay? Because unnecessarily, if you're missing out something, if you're getting a poor grade, then you are going to be, I mean, the impact is bad. Bad impact is going to be on to you. So that is what I mean. It's really important that you're staying in the classroom. You're listening to your teachers. You are participating in the discussions. So that is going to be help you to learn more and to get a good grade. Okay. Okay. So
Hello, sir.
yeah, that's all.
Sir, actually, sir, I didn't understood accurately, sir. If you repeat this operation, then it will be better for me, sir.
How about the others? That is what I mean. I would actually I want this, right, Russell? What
Ye-
I said in the last
yes,
class,
sir.
I said that all
Sir,
the
because
students.
sir, yes, sir.
Mm,
Last class, sir, I have faced lot of internet problem. That's why, sir, I have much more time. I reconnect, sir. That's why, sir, I cannot properly concentrate to your class. This is the main issue, sir. And another issue, sir, I didn't find this slide. That's why, sir, I don't
huh?
see it.
I have uploaded this file on the Facebook group, right?
Yes, sir. You uploaded, but sir, I have face in my phone, sir. That's why it will
Okay.
make me
Anyway, so let me ask that the first all the students that anybody has this task. Have done this task or not? Is there anyone who has practiced with the note khata and pen? Anyone? There are total 34 students in this classroom. Out of 34, nobody has done. Is there anyone that did it? I think everyone has forgot. Am I correct?
Yes, sir.
Yes, sir. Sorry, sir.
Didn't
Yes, sir.
forward, but
Yeah, it happens. You know that because it has been asked you before 1 week time. So that's why I say it on that day itself. That practice it tonight itself, right? That if you are getting any task, do it immediately. Otherwise, you can forget. Otherwise, you can miss out something. So it happens. It happens. But it happened. But the fact here is that 34 students followed. It's a bit surprising to me. Yeah, I can remember that in the other section I have given this task, and they have that the next day class. And out of the 35 students, only 5 students have practiced. So this was also I did not lie. Anyway, so you must have to practice it. Why I am pushing it? Look at when I am giving some homeworks to you, so you have to understand that this topic is really important. And yes, and I said, I declared, I always, if I am teaching something to the students, I always declare that this is very important for you, this exam, that exam. So you must have to do it. If you're not doing it, in that if it is a problem coming, this type of problem is coming into the exam, in the midterm or final, it is not going to be come with the 5 or 10 marks. It is going to be come with the at least 15 to 20 marks. So look that if you're missing that the 20 marks, if you cannot answer it correctly, then you are missing the grade B plus, even B plus also you're missing. If you're getting 80 out of 80, that is going to be B minus. Even not B is going to be there. So this is what I'm saying. That whenever I'm saying to you something is very important, really important, so give your whole concentration over there and practice it immediately at your home. Okay. So please do it. So should we repeat this? This explanation, or should we progress with that?
Yes, sir.
Okay, so this is a let me brief. I mean, have a brief discussion on it. We are not going to be go for the detail, but we are going to be use the three pictures. There are so many pictures are there. So as because we are having the three instructions, actually we are working on these three instructions. That we are having a memory location. We are having that the memory that is our RAM actually. This is our RAM actually. On that the RAM we are having the different locations. So the location number is going to be 0 to n. So here that I mean we are showing that the location number is 9 to 14, for example, and that 99. It can be any location number we can show here as an example, right? And of course that everything we are using here with that the decimal number. So in reality it is with that binary number that you are not confusing with this, that why we are using that the decimal number. So this is only for simplicity that actually we use the real numbers. So here we are talking, we are actually working on this fetch, decode, and execute for that these three instructions that in a program that the three instructions is there: the load 10, add element, store 12. So we would like to see that okay how that the CPU is going to be execute these three instructions. So this is that the already we have learned it out from this lecture that an instruction has two parts. One is that the output, that is load, and that is that the operand. Okay, so that means operation code, operand code. So operand code is can be itself, it can be a data, or it can be that a address, okay, address of the memory location. So that you can load, you can take the operation, you can read that the information from that the location, so you can write that the information on that the location. So it is talking about the load 10. So that means it is talking about that okay load that the value or data that is actually stored into the 10. So you can see that the location number 10 we are having a value 2. So that means when it is going to be executed into the CPU, that means by seeing the decoding unit, by seeing this instruction, by saying this opcode and operand, it is going to be understand that I have to store, I have to load the data from that the memory location number 10. That's what I have. So how it is going to be done? Actually, that the three instructions we are having, how these three things are going to be done. That is actually we would like to see here, and that's why we are showing here these three instructions and the values on the memory, and we are having here that the rectangular shape, this box you can see. We are having here that the our processor. So inside the processor there are many components are there, but the components we need to show this fetch, decode, and execute operation, that only we have included. Like that we are having some registers like program counter register, instruction register, memory address register, memory data register. So we are having these registers. We are having the control unit. We know that our processor has that the main two components, the ALU and CU. So this is the control unit. While the decoding part is going to be done, and this is my ALU. Basically, these are the combined one, but we have to make it separate. The ALU and register, general purpose register. We are separating it. That's why I make it in the same box, right? So to make sure that actually it is, you understand that it is actually inside of ALU. So this is the fact here that we are separating it. Why? Reason that we want to see the operations, that how it is going to be done, how it is going to be step by step it is going to be done. That's why actually you have kept like that, so that the ALU, the general purpose register, so these are the part of the CPU where the operations are going to be done, or instructions operations is going to be done. So that whatever that the operations are going to be done, that the decision will come from, that the action is going to be taken from the decoding unit. Why? Because decoding unit is going to be understand that an instruction, what it is telling, what is the meaning of that instructions. So that is actually it's translating that exactly what it is going to be done into the CPU. Okay, that's why we say it that in the decode part, after fetching the instruction, the decode part is going to be translate the instructions. Okay, so this is what we want to see. Now we are going to be see with that. Uh, okay, let me bring that the last slide for that the first operation. Okay, we can explain it from there on. Okay, so from here on. So what is happening the first step? Okay, I think it is going to be difficult because we should have to talk about the PC address. So when that, I mean, we are taking this example to show that the page decoder and execute. So, program counter is a register who keeps the address of the memory, which instruction is going to be executed next. So that the first of all, you're supposing it is 100 because the first instruction stored into the 100. So that in the PC you are using 100. So if we want to fetch these instructions, which is stored into the location number 100, then what we have to do, we have to first need to be take these instructions, the location address 100 in memory address register. So when that memory register address register having some address, so that means CPU is ready to fetch something from the memory or to write something to that the memory. So whatever that the things you want to do, the CPU wants to do. If CPU want to fetch something from the memory, or if you CPU want to write something onto the memory, the address location must be to be into the MAR. So that 100 you're bringing into that MAR. So when you're bringing it here, that means now the CPU knows that, okay, I have to fetch the data from the location number 100. So this is my 100. So this is the another register, the MDR. So that means if you want to read something from the memory with the location number 100, when it is in the MDR, so MDR is ready to fetch. Or when the location number is something else, that I mean you want to store the data, that will also bring to that the MDR. So this is a medium, so that actually the data will come from that the memory and data will go to that the memory. So this is the, so that means when it is the 100 is here, so you are ready to actually fetch the data from the location number 100. So what you are doing, so you are fetching that the data next step. You are fetching the data here, the log 10. So this is the instructions will come here. So when that the instruction comes here, the log 10, so that when it is going to be come to MDR, then it is going to be taken to your current IR, so the current instruction register. So you know that before the discussions we have done. So when it is going to be come to that the current instruction register from the MDR, the log 10 or any instruction, on that time it is ready. It is being ready to actually executing. Okay, it is the current. You know that the IR is a register which one actually holds the current executions data, current execution instruction or current execution instruction address. So this is that currently being executing. That what the currently being executing, that is going to be placed into the IR register. So when it comes to that the load here, the load 10. I'm sorry, that load 10. Okay. When it is executing, so the load 10 you have fetched from the memory, and when it is in the MDR, you are fetching it in the MDR now, and from the MDR you are taking it to the current instruction. When it is current instruction register, that means it is already in action. Okay, so that means now you are ready to actually update your program counter register. So how you are going to be update? Formula is simply that PC plus 1. So that the address number is here, that it is already here, that the 100. So with that, it's going to be plus 1. So what is going to be the result? 101. Get it? Do you understand?
Yes, sir.
Yeah. So now, so when, I mean, this is that the update has done. So now when the current register, instruction register load 10 is here, and that it is going to be sent to that the decoder unit. So it is going to be placed to that the CEU. So that is going to be actually for decoding purposes, that the load 10. So by seeing that the load 10, so if it is that the load 10 here into the control unit, so by seeing that the instructions, the decode unit is going to be by seeing that the opcode, the decoding is going to be understand that okay, I should have to load. So that means with this instruction, the operation is going to be load something that has been stored into the location number 10. So that is what from the decoding unit, the control unit is going to be asked to the MAR, so that the MAR to load the data which one is stored into that location number 10. So that means we must have to be update the MAR. We say that something we want to read, something we want to write, the address must need to be placed into the MAR. So that is what we are going to be update this to 10, right? Because this is my operand is telling that it is the address of the memory that the information we want to load into that the CPU. So that means when it is going to become 10, so that means now it is the CPU is ready to actually load the data or fetch the data from that the memory. So from where location number 10, so that means now it is going to be we bring that the data is going to be fetch the data from the location number 10. So when the MAR is giving the address 10, so you can now fetch the data from the location number 10. So what is actually your data? That is actually your the data is 2, right? So now that when it is come to that the MDR, so it's a data that is going to be now placed into that the general purpose system 2. Okay, so that is how that in the instructions it was the load 10. So that means you have successfully load the data 2 to that the CPU. So this is how that the first instruction execution has been done. do you understand it? Is it clear?
Yes, sir.
Here. So you can see here that the final one. So I say that you should have to only draw single picture for that the single instructions. There I have given so many slides. Why? Because you can see that step by step how the operations are going on. So if you're drawing it at once at your home, then I think you are going to be very much clear that how the things are going to be happening. You're never going to be forget. That's my view. So you can see here that the same thing, that the results we have got, that the finally the 2 has been loaded into that into the general purpose register. So you can see that the first step was it was 100. So we have bring that the 100 MAR. Then we have 100 from the 100 location load 10. We are having fetching into that. In the second step, we have fetched into that the MDR. From the MDR in the third step, we have taken the load 10 into the current IR, and we have updated in the fourth step the PC plus 1, 100 plus 1. So it was the 101, and then we have taken this load 10 into the decode unit. Then step number 5. And after that, when it has been seen that it should need to be load, the CPU should need to be load the data located into the memory number 10. Then in the 6 we have updated the location 10. So because this is the 10, we have given the location number 10, and then we have bring that the fetch that the data from the memory location number 10, that is 2. So we have bring that the 2 into the MDR. That is my 7th step, and the 8th step I have taken that 2 to that the general purpose register. Is it clear? So if this type of problems comes into your exam, then you should have to draw this draw the single figure like that, and with that single figure you're going to be show the step. It's better that you show here 100, right, and cut it and show that in the fourth step it is going to be 101. So it is going to be like that, the answer, the way you want to give. So like that here, you have bring the log 10. So when you are writing on the scripts that it is log 10, that you have actually bring from that the location number 100. So just make it cross to show that the next one. Do you understand that? So it can be easily visible that how you have bring the things step by step. Get it or not?
Yes, sir.
Yes, sir.
Like here, it was that first time you have taken the 100. So when you want to updated that the 10, the MAR, so just make a cut like that, so that I can understand that okay, it is going to be you have updated this with that when the step number 6 happens. Do you understand that?
Yes, sir.
Okay, so now come to that the next one, that the add element. So that for that we want to see. So I might to see from that directly on the 11. Yeah. Yeah, here we are having total 12. Here we are having total 12 steps for the next instruction. The next instruction is add 11. So location, in the location we had that actually 101. Okay. So in the first step that we have bring that the 101 into this MAR. So that 101 with that the 101 we have learned it out that okay that CPU is ready to fetch that the data instructions from that the uh, 101 location. So that is the 101, that is the add 11. So in the second step we have brought it that the add 11 here and 11 here. So when that the add 11 comes to the here, in the third step we have taken the add 11 into the current IR to the third step. So when that it comes to that the IR, then we are updating that the location address, okay, of the PC. So that means it is going to be 101 plus 1. So then the fourth step, it has been updated to that the 102. So that is the next instruction actually will be executed later on. So now that I mean, when the add 11 you are having now, so in the next step, the fifth step, you are taking this add 11 to that the CU. So now CU is saying that okay, this is my operation code and this is my operand code. So it is that telling the add, right? So it is telling the add. So that means this is an operation is going to be done by the accumulator. That is going to be done by the execution unit, the calculations, that arithmetic logic unit. So arithmetic job is going to be done by the ALU. So that means now it is telling to tell to that the processor. Now it is going to be tell to that the processor. Okay, it is sending an instructions to that the process ALU that okay, you should have to add. So what you should have to add, with what you should have to add, that is actually the instructions. The instructions you are having. The instructions you are having into that your general purpose register, that you should have to add. So what exactly you are doing here? What exactly you are doing here is that in the general purpose register you are having, when that add comes in the general purpose register, what you have bring that the value 2 into ALU. So that is actually happened here. I think that if you are seeing here, that is going to be understandable. So look that it has bring that the ALU to the ALU, it has been bring that the 2 in the 7th step. Okay. So now now that I mean here that what is going to be happen. So now when that you have bring the 2, so now what is the next step? The next step that you should have to be bring that the data from the location number 11. That means, and that the 8th step you are just updating that your MAR, that is the location number 11. So now you are going to be go to the so that means you are ready to fetch the data from the location number 11. So what is the data you are having? 3. So now you are actually bringing that 3 into that MDR. Okay, so that the 3 data from the location number 11 bring to that the MDR. So now these 3 you are sending it to that. Sorry, in the 10th step you are sending it to that the general purpose register. So now that the 3 you are bringing here. So now you are going to be do the job, the addition job, the 3 and the 2. So you are getting the result 5. That is your 11th number step. So now that the result 5 you have got, that you are sending it to that the general purpose register, and it is going to be stored there temporarily. That is 5. Get it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So this is how that I mean, this is my last step that I mean I have now the execution unit has executed the instructions, and that is actually the addition and the result has stored into the general purpose register temporarily. So this is that I mean Second instruction execution is done. Now the third instruction. Okay, the third instruction is the store 12. So now what you are going to be do that you are taking that the location of the in the PC you are having the location number 102. So you are bringing that instruction, bringing that address 102 that into the MER. So when you bring that to that the MER, that means you are ready to actually bring that the instructions to that the MDR. What is that? That is the store. That is the store 12. So now you are bringing this into that current instruction register. That is going to be why it is irrelevant. Okay, I think that this instruction anyway, the update is going to be done later on, I guess. Okay, so this is what actually I was trying to show to you, that actually store 12, it is going to be taken into the current instruction register. So when it comes to the current instruction register name, you are just updating that your PC plus 1, so it is going to be now 102 to the 103. So in the 103 actually nothing is there, right? So that means actually it can be happen, this is the ending of the operation of this load and store. So when it comes to it has been updated. Now your job is going to be bring that into the the control unit. So you can see here the store 12 has been taken here. So now when it comes so that now my operation code is stored and my operand code is 12. So that means it is by decoding unit that it is going to be understandable that okay, we want to store some data that is having with that the CPU execution unit into the location number 12 of the memory. So here actually we want to store the data. So that's you understand. So what the data is going to be stored, that the result temporarily is actually stored into that the general purpose register, the result 5. So that the 5 is going to be stored into the location number 12. So to do that, what we are going to be doing? To do that, this is the location number 12 should need to be bring into that the MER. So it is going to be 12. Okay, so when it comes to that MER, that means now you are ready to store that the result so into the memory location number 12. So now you are going to bring that the result to here, that is result is 5 in the MDR. So you're taking the result into the MDR from the general purpose register, and from the MDR you are going to be read it here in the location number 12, right? 12 the 5. So that is actually, with that actually it is going to be job, the job is going to be done as you can see here. So that is the 12 updated. So then it has been taken the 5 into the MDR, and from the MDR to that the location number 12. Clear?
Yes, sir.
Yeah, so make sure that you're practicing at your home, right? So with the pen and note khata. So I'm going to ask it tomorrow. So this time I would like to see that all of you, all the students of the class are practicing, are doing this home task, and with that actually you're coming to tomorrow's class. I don't want to hear from anyone of you that actually, sir, I did not prepare it or I did not understand it. Okay?
Okay, sir.
All right, sir.
Yes, sir.
Okay, sir.
Yes, sir.
Okay, thank you. So now here we are having a block diagram of a basic uniprocessor CPU computer. So that the uniprocessor means here nothing, but it is talking about the single core processor actually. The uniprocessor, the multi-core processor means if it is more than one core inside the microprocessor, then we call it the multi-core processor. And actually uniprocessor means that there is a single processor, uniprocessor, a single core inside of that the processor. So this is the block diagram. It is trying to show to you that actually what are the things are actually inside. So these are the red colors or the black colors arrow signs you're seeing, that actually these are the showing that some the connections between that each of the units that what we are having inside a CPU. So you can see that, I mean, we have given that the definition that the input, output, and storage, and that the processing unit. So into here that you can see that inside of the processor, you're having the register and the combinational logic. So this is the part of the ALU, and here you are having the control unit. So that is actually the CEU. So that actually it is showing that how that, I mean, they are interconnected with each other. And in that the notes of the lecture 3 I have given on there, you're going to be get a bit discussion about this figure. So if you are reading this, you'll easily understand it. So there is nothing new to actually explain here. That actually we have already done it. Now we want to move to that a new topic that is I mean, that is actually for fetching part. We have done here with that the fetch record, the CPU operations. Now in that, if you're looking to that the fetching part, what's that? Fetching should be before operation. Here it is. So in the fetching part, we have said it that yeah. So retrieve from relatively slow memory, causing the CPU to stall while waiting for the instruction to be returned. So we said we want to overcome this by these two techniques. One is the cache and pipeline architecture. So this is now our target. We would actually look to look after these two things, that the cache memory and the pipeline architecture. So that is going to be our next discussions actually around. So we have already learned the definition for the cache memory. We have already get some good sort of information about the cache memory. You said that actually it is a type of a memory that is going to be in between the CPU and RAM, and it is going to be actually stored. The cache memory is going to be stored some instructions in advance with it, so that if when CPU is doing some operations, the execution is doing some operations. If it needs something, it is going to be get. It may possibly get that needed instructions or needed operands from that cache memory. So that we have already discussed. So it's already saying that why we need a cache memory, because of the speed conflict between that the RAM with that processor. So we know that, I mean, the CPU is the fastest processor is the fastest component into our computer system. But if you're comparing that the memory, the RAM, with that the processor, then actually it's RAM is quite slower than the processor. So that is one the speed conflict comes out. So it said the CPU cache used by central processing unit of a computer to reduce the average time to access memory. So that is what actually we have already discussed in our previous classes. So we have also said that there are 3 different levels of caches. Can you hear me now?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, there is an internet issue. Can you see the slide?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So that is what I was trying to say here. The cache is a smaller, faster memory that stores copies of most frequently used data. So that already we have discussed. These are the facts. So here we want to see that actually what is happening. It is telling that cache RAM is much faster than the normal RAM. We know that, and that is why we are telling that, okay, we are going to have the cache memory in between the processors and that the RAM, so that actually we can we do not need to go to the RAM frequently, as because it has that the slower device compared with that your CPU. So that is what it's telling, that if you are having the cache memory here, then it is going to be if CPU is doing something, CPU will be able to ask that the high-speed cache memory to give these operands, and if it is happy. If it is having this, then actually it is going to be respond with. So that is actually the talking about the constant data movement between that the sequences. So you do not need to go every time to that the RAM, as we know that this is a place is actually highly traffic area that between the CPU and RAM. So it is going to be useful, and I mean, if the cache memory is there. And there is also another thing, come to the discussion about the bottleneck problem. So this is that if you just look to this word, the bottleneck, so you can understand that, I mean, if you're thinking about a water bottle or maybe any cold drinks bottle, so you'll say that the neck of that the bottle is actually thin, very thin. So so when you are trying to pour the water from the bottle to glass, you'll see that I mean, that much of water will be able to, I mean, pour at the time that, I mean, the neck, according to the neck. If the neck is smaller, then it is going to become with that, if it is very thin, then it is become like that the drop of water. If it is a bit bigger, then it is going to become with a frequency, with a, I mean, with a speed maybe more than more that the bigger neck you are having of the bottle, that more quickly you can actually pour that the water or cold drinks from the bottle to the glass. So this is what, I mean, it is trying to show you that the neck of that bottle here, so between that the CPU and RAM. So when you do not have that the cache memory, that is actually happening, because I said already that this is a high traffic area, so that it's a very busy area basically between the CPU and RAM. So if the cache memory is not there, so you already know it, that, I mean, if the CPU is doing some operations, it must need to be asked to that the RAM that, okay, give me these operands. So the RAM is going to be search it and find it, and then it is going to be returned back to the CPU. So that already we have discussed. But it is also telling that, I mean, that the communication between the CPU and RAM, this is actually going to be a very hard traffic area. So but the neck is smaller. But you are trying to ask, you are trying and asking for that the more data that easily it is actually passing between that the CPU and RAM. So that is actually that the problem starts here, that the bottleneck problem. This is the problem is actually so that the bottleneck problem. So I mean, we do not have actually sufficient space or sufficient sufficient speed. Here the neck is more slim, so we are so if we are willing to access something from the RAM, so that is going to be time consuming, right? So it is going to be take more time, because the bottle neck is thin. So this is what the problem. So that the problem is known as the bottleneck problem. So that the bottleneck problem can be actually it is going to be happen into that computer, not only for these purposes. There are some other purposes can also the bottleneck problem come, as because you are trying to making the different components of the computer to make them communicate. You are using the bus lines, right? So you have to understand that how much data you are passing between that between the two components, right? So that the path is free or not. There are actually several issues will come there, that when you are going to be considering that the CPU's condition, that the bus lines, that, I mean, how much info paths you are having, how much load actually they'll be able to take. So there are several questions will come. So this is the problem here. We are talking about the bottleneck problem between the CPU and RAM. So to solve this problem, basically there are several approaches. There are several techniques are there. One of the techniques is actually cache memory. So that actually already we have explained that how the cache memory works. So when the cache memory is going to be there, so CPU does not need to go frequently to the RAM while he's doing some operations, because you're having the cache memory. So that means the instructions operands are going to be able to getable from the cache memory itself. So you do not need to go to the RAM. So that means somewhat or some sort of load you're reducing with the cache memory. So because the cache memory is going to be I mean, in advance it is going to be stored some instructions that may be going to be used by the CPU. So this is what I mean, with cache memory, that you can reduce that bottleneck problem. So it is telling that if a cache increases the CPU's capacity to fetch the right data from the RAM. So that is what only that necessary data you will be getting from the RAM. Otherwise, that the CPU is doing some operation, those if it needs something, it is going to be get that the instructions with the cache memory. So we have already said it, that we are having that the different level of caches. If the caches is like L1, L2, so that you are having that the CPU here. So we have already said it, that CPU needs something that it is going to be asked to that the L1 cache. Do you have these instructions? So if it is having the instructions, that we call the cache hit. So that means that is going to be sent immediately, that instructions to the CPU or with the execution unit. So that, I mean, if it is not there in the L1, so that we call the cache miss. So then in that case, it is going to be go to the L2. So if it is there, then it is going to be called the cache hit. If it is not there, then it is going to be cache hit. So it is going to be sent to the L1 and L1 to get the ALU. And then if it is not there, then we're going to be tell it's cache miss. Then it is going to be checked for the L3. Is it there? So if it is there, then it is going to be called the cache hit. So it is going to be sent to L2, L1, and then the CPU. And then if it is not there, then it will go to cache miss. On that time, it should need to go to the RAM, the main memory. So because we are having the maximum 3 cache memory level of caches that the CPU. So all of them are inside these days. But this discussion is going to give us an idea that actually the cache memory was not all the cache levels was not inside the CPU. So slowly that has been growth, and actually that has been placed inside the microprocessor. So we'll continue the discussions from here on. That the slide number 56, remember that we have done up to the slide number 55. Our class time is over. So if you have any questions or any comments, you can tell.
No, sir.
Okay then. Thank